So this is actually the very first puzzle that I started sending out on holiday letters because a friend of mine sent it to me. It's a very simple problem. It goes like this. The ages of a ship and its boiler add up to 42 years. The ship is twice as old as the boiler was when the ship was as old as the boiler is now. Pretty simple, right? One clue, the ship is not twice as old as the boiler is. That would be pretty easy. The ship would be 28 and the boiler is 14. But that's not the problem statement. So let me repeat the problem statement. The ship is twice as old as the boiler was when the ship was as old as the boiler is now. Now we can pause here and we can talk about the solution. So I usually give this to third graders and I send it home with them. And I get calls from parents saying, my child has not had algebra yet. And how are you giving them problems that require algebra? And I say, this doesn't require algebra. We solve it in our heads. And come to my class and I'll show you how we do that. And it's real easy. First of all, we have to ask, what's the question? The question is, or the problem statement is, the ship is twice as old as the boiler was when the ship was as old as the boiler is. So the first thing we have to decide is which is older, the ship or the boiler? Well, most people would say if the ship is as old as the boiler was when the ship was as old as the boiler is, that means at some time in the past, the ship was as old as the boiler is. So the ship is older than the boiler. Great. So what's the youngest that the ship could be and still be older than the boiler? Well, if the two ages add up to 42, they can't each be 21 because the ship wouldn't be older. So the first intelligent guess would be 22 and 20. So if the ship is 22 and the boiler's 20, how far apart are they? 2 years. Well, 2 years ago, how old was the boiler? Well, 20 minus 2 is 18. Is the ship now twice as old as the boiler was then? No, 22 is not twice 18. So what's the next intelligent guess? Well, it wouldn't be 23 because that's not an even number. And if it's going to be twice something, it's got to be an even number. Let's try 24. Well, if the ship is 24, how old is the boiler? Let's see, I added 2 years to the ship. So I got to take 2 years away from the boiler. So that would be 24 and 18. Well, how far apart are they now? Well, 6 years. So 6 years ago, how old was the boiler? Well, 18 minus 6 is 12. Is the ship at 24 now twice 12? Yep, done. Intelligent guess and check is a powerful technique. In fact, it's the primary technique that your doctor uses. If you go to the doctor and say, my head hurts and my right toe hurts, the doctor isn't going to pull out the book of internal medicine and look up and see all the possible situations that might be a problem with your right toe and your head. You may have a cold and you stubbed your toe. Let's try that first. So maybe I'll give you some headache medication and tell you to go soak your toe. And if that doesn't work, then come back and we'll talk about another possible solution. So guess and check is a typical way to address a lot of problems in the world. Now, it's helpful to have algebra if you have a more complicated problem, like a church and its bell tower together add up to 1,000 years, and the church is 7 times as old as the bell tower was when the church was as old as the bell tower is now. Algebra would probably be a useful tool to have, but guess and check is still a good tool. And if you don't know algebra, it's a really good tool.